1984, a subsea template was installed in the Balmoral field in the North Sea, completing the first phase in the development of the field. For the first time ever, a purpose-built floating production vessel will be used to exploit oil from a North Sea field. A system which North Sea Sun Oil and their partners believe will be more cost-effective than a conventional platform. The template contains 14 slots for drilling those wells immediately below it, plus multiple connections linking it to 8 satellite wells located in other parts of the field. The floating production vessel will be linked to the template by flexible risers. Thus, the entire output of the field will pass through the risers to and from the production vessel.
The riser base is going to disappear.
The template was designed by Seaflow Pell Frischmann, engineering consultants, in collaboration with Sun Oil. Work on the detailed design began in January 1983.
This riser base is now going to be off.
The first design was rectangular, based on a rigid riser connected directly over the template. This rectangular shape was found to be unsuitable for the use of flexible risers, which are connected to the template on either side.
We need to look at a different concept altogether.
Hello, Jean-Luc.
Make a sketch and...
The breakthrough came with the design of a template containing the 14 wellheads in a center section and the manifolds in 2 wings on either side.
Like that. Okay, to have this. Something like that?
That looks a viable arrangement.
Yes. And the manifolds, they are very schematic. You don't see the piping. There is no detail there. But that's the overall aspect of the template when the construction will be completed. Now, if we look at this drawing, you have the template on the seabed.
The octagonal plan was examined by the project team led by Terry Mahoney, the project director.
Nigel, you're satisfied with the structural arrangement?
Feel quite heavy.
Okay. Jack?
No, I think we've got a good design here. We should go ahead with it.
Okay, I think then let's go ahead and bid it and get on with the work.
In September 1983, Bechtel GB Limited, the managing contractors, awarded a contract to Kestrel Marine at Dundee for the fabrication of the template. In order to avoid delays in construction during the Scottish winter, it was agreed that the template must be fabricated indoors. But it was too large to be built in a workshop in one piece. The center section and the 2 wings were therefore built separately. By the 16th of April 1984, the initial fabrication of the template sections was complete. First, the center section, weighing more than 400 tons, was removed from the workshop on a multi-wheel trailer. It was transported to a dockside position by the River Tay. It was supported on concrete pedestals, accurately sighted and leveled. The first of the 2 wings was then taken to the dockside. The wing was carefully leveled and mated to the center section, and the 2 sections were welded. Then the second wing was added. Finally, the pile sleeves were brought to the site. During these final stages of fabrication, work continued day and night. The entire structure was weighed. It registered 840 tons, and a trial leveling was carried out prior to load-out. A seagoing barge arrived with the 3 piles already sea-fastened on deck, and load-out took place on June the 4th. The slings needed to lift the template at sea were attached to 4 pad-eyes. The strain which would be put on it during the lifting phase had been a major factor in shaping the design. The transport barge was placed in position at right angles to the dock, while the tide raised it to the correct level. Then the template, 100 feet each way and 33 feet high, was raised from the pedestals by 2 sets of bogies. The template was pushed and winched onto the barge. As the weight of the template was transferred from the dock, ballast water was pumped out of the barge to maintain the level. Loaded on the barge, the template was sea-fastened and made ready for sail away. The long voyage to the Balmoral field began at 7 a.m. on June the 17th. A heavy lift crane vessel was also on its way to the Balmoral field. Equipment for use during the installation operation was unloaded from a supply boat and stowed on the deck of the crane vessel along with its various attachments. The barge arrived from the River Tay after a journey of 200 miles, which took 27 hours. Two remotely operated vehicles were lowered into the water in their garages. The ROVs contained TV cameras and other instruments in communication with the control center on the barge. The sea fastenings were cut from the barge and the template was ready for installation. As the crane raised the lifting slings, the soft ropes securing them to the template frame were snapped one by one till the pad eyes took the strain. Transponders on the template reacted with a corresponding set on a grid on the seabed in order to locate the structure. Gyros and inclinometers monitored the angle and the level. All this information, fed through computers, enabled the engineers to position the template by adjusting the crane and other control lines. So accurate was the initial positioning that in the event, very little adjustment was needed to sight the template well within the tolerances allowed. Only 5 feet off target, 3 degrees off heading, and 0.6 of a degree off level. To begin the last phase of installation, the lifting slings were removed from the template with the help of divers. Then the first of the piles, 230 feet long, 42 inches in diameter, was lowered from the surface, suspended from the underwater hammer by a welded connection. Film from the ROVs shows the operation. The end of the pile is guided into the sleeve by the stabbing guides at the top of the pile sleeves. On reaching the bottom of the sleeve, the pile sinks 54 feet into the soft seabed under its own weight. The first blow from the hammer breaks the welded connection with the pile, which is then driven to its total depth of 190 feet into the seabed. In a final operation, the piles were secured inside the sleeves to prevent any further movement. For the first time in the North Sea, the hydrolock swaging tool made by British Underwater Engineering was used for this purpose instead of a conventional system of grouting. The tool is lowered into the pile. A pressure of 10,000 psi is applied via the hydraulic power line, plastically deforming a section of the pile, increasing its diameter by 2 inches, and thus locking it into pre-cut circular grooves in the sleeves. The template is now pinned firmly to the seabed. With the template successfully installed, a drilling rig, Western Pacesetter 1, was positioned over it. The rig will drill 11 wells through the template, leading up to the start of production in 1987. So ends Phase 1 in the development of the Balmoral field. Phase 2 is already progressing fast.
middle of the North Sea, the halfway point has now been reached in the execution of an innovative plan to develop the marginal field called Balmoral. When the project is completed, the world's first purpose-built floating production vessel will be permanently on station here. Beneath the surface will be the gently curving flexible risers, connecting the subsea template with the production vessel above. The template is 470 feet below the surface and provides a platform for 10 production wells, as well as a focal point for flow lines from 9 outlying satellite wells. Manifolds on the template will control the flow of crude oil and water, and the manifolds in turn are controlled by an umbilical from the surface. Phase 1, which ended in the summer of 1984, saw the lowering of the 840-ton template onto the seabed. Phase 2 began once the template was positioned. During the following 12 months, 3 main activities were planned to run in parallel. Drilling was to continue throughout the year out on the Balmoral field. Beneath the sea, the work of installing flow lines, riser bases, and the export pipeline was to be largely completed during this period. Meanwhile, in Sweden, the construction of the floating production vessel was to provide one of the highlights of this second phase of the project. Work began with the blasting and priming of steel plate before marking and cutting started. From the sub-assembly shop, each unit was transferred to the main assembly hall before then moving outside. Pipe towers would soon be permanently installed in the columns of the floating production vessel. Gradually, the prefabricated components were brought together. In Scotland and England, further sections of the vessel took shape. Columns, pontoon tips and 4 deck blocks were all subcontracted to Scott Lithgow, Cleveland Redpath Fabricators and Motherwell Bridge. The floating production vessel was growing fast. Senior management of Sun Oil visited Sweden in February to see the work progressing. Temperature, minus 25 degrees centigrade. Even the sea was frozen. Hard to believe that within a few months it would be summer. 140 feet high, the completed vessel will weigh 16,000 tons. The derrick is assembled. The vessel will be capable of drilling and well workover. As the structure took shape in the spring and summer of 1985, bulk storage equipment was enclosed in the columns. Deck blocks were installed, partly outfitted with such items as compressors and switchgear. The final piece of this enormous jigsaw puzzle was then dropped into place. The deck was now complete. The thrusters were tested at their place of manufacture in Chesterfield. They will be installed once the floating production vessel is in deep water. Sun managers visited suppliers at all important stages in the work. The deck cranes will soon be installed on the floating production vessel so that they can assist in the construction. The casting of the Wildcat. This will guide the anchor chains through the winches on the floating production vessel. computer, which will control the entire subsea system, is tested and accepted by Sun. Sun's new operations headquarters in Aberdeen are prepared for the ending of the construction phase on Balmoral and first oil.
That's the secretarial workstation, standard secretarial workstation.
They anticipate having this floor complete by when, Jim?
The first week in August.
Temporarily working in the Sun warehouses on the edge of Aberdeen, operations have the responsibility for planning and controlling all the development drilling on the Balmoral field. The strategy for the Balmoral field requires all wells to be completed by the first oil date of February 1987. Four existing wells drilled during the exploration phase are to be used in the development of the field. Development drilling began in January 1984 with the drilling of 3 satellite wells. In June of that year, the subsea template was installed, and in the following 11 months, 6 deviated wells were drilled through it. The drilling rig then moved off the template in the summer of 1985 to allow for the installation of riser bases, flow lines, and the export pipeline. 2 satellite injection wells were drilled during this time. After the completion of Phase 2, we will see the drilling of 4 more template wells. Completion of the wells will begin in February 1986. During the summer of that year, the floating production vessel will complete any remaining template wells. The flexible risers have been armored and coated with plastic. Their job will be to link the production vessel with the seabed template. These will be ready for installation next year. Water injection trees are prepared for their 470-foot journey to the seabed. All subsea units are painted white to aid the divers' work in the murky water of the North Sea. The blowout preventer is also made ready for operation.
Let's see, our real problem is down here in keeping on the template as long as we can.
In London, as work on the floating production vessel and its equipment progressed, so the schedule for offshore operations was being pushed forward and finalized.
So basically, by the end...
The moment in the carefully laid plan had now arrived when the installation of subsea flow lines and manifolds would start.
Okay, then let's do it that way, shall we?
The 14-inch steel pipe was now prepared for a one-way sea voyage to the center of the North Sea, coiled like rope around a huge drum. Before departure, a trial length was unwound to ensure that it would straighten and retain its roundness during laying. The 1985 Balmoral offshore installation program involved no less than 5 vessels. Nine miles of 14-inch export pipeline were laid to take the crude oil from Balmoral to the existing Bray 40's trunk line. In addition, over 20 miles of flow line of 2-inch, 4-inch and 6-inch diameter was laid to the 9 satellite wells. As the pipe uncoiled, it was straightened. Before laying, anodes were attached to protect the pipe against corrosion. appraisal of the offshore construction program now considered the merits of installing the manifold system a year earlier than originally planned. Work was intensified in the project team and at the manufacturers to meet the new deadline. It was met, and in August 1985, the manifolds provided an unusual procession in the streets of Aberdeen. The heaviest manifold weighed 85 tons. These, the first fully retrievable manifolds in the North Sea, were lowered onto the seabed by the semi-submersible Safe Carinia. They're compact in design to allow for ease in handling. Guidelines ensured that the manifolds located correctly onto the template far below. All 3 manifolds were placed in position in 2 days. The lowering was monitored by remotely operated subsea cameras. Seawater floods into the dry dock, and the production vessel floats for the first time. The world's first purpose-built vessel of its kind. It is not just a hull. When completed, it will provide a self-sufficient office, processing plant, and home for 120 people. It will carry a sophisticated communication center. It will contain facilities for air and sea transport and support a full diving system. It will provide an economic solution to the production of oil from marginal fields. The next phase will see the completion of construction, and then the operations team will take over as Balmoral heads for first oil.
This is Comex Holder Diving Limited's RCV 225 on board the Western Pacesetter 1. Today is the 19th of July 1986. And at the moment the RCV, or the remote control vehicle, is sitting in the launch box at a depth of 131.9 metres. All the fish we can see in the foreground are attracted by the lights on the remote control vehicle. Tends to bring them in the close proximity of the lights, where they can seek out food, i.e. prawns, plankton, etc., to make them big and strong. Most of the fish we see will inevitably end up in our fish fingers. The RCV has now left the launching basket, or the launcher as we call it, which is what's in the centre of the picture, the big white object. This is deployed from the surface by means of a winch cable, and we can see the RCV tether, or the umbilical, being wound in and out by the baling system on the launcher. This enables the vehicle to leave the cage and travel to distance of 400 foot in any given direction, which results in a radius of 800 feet. At the moment, the RCV has flown around the back of the launcher and is showing the bailing system, which enables the umbilical to be fed out from the drum, which is in the centre of the picture at the moment. Now we see the tether being wound out. And again being wound back in. As we can see, it's pretty dark at this depth. The lights we can see in the distance there is from the diver who is working over on the Balmoral Template. The vehicle will shortly be going over to the diver and just having a look what he's up to. As we approach the diver, he has in fact just come out of the diving bell and is just doing his final pre-dive checks before leaving the bell and going across to the work site. The diver carries a head-mounted camera which is attached to his helmet, which has a powerful light, as in a miner's helmet for working underground. The only difference between a diver and a miner is a miner gets dirty and a diver gets wet. Nonetheless, they both wear the same headgear. We're having an overall shot of the diving bell at the moment, the diving bell umbilical to the left of the picture, and the winch wire alongside it, which is now in the left hand side of our picture. We can see the onboard gas bottles for the bell. These are here in the event of an emergency, i.e. the main umbilical with the surface getting severed. Then the divers would have to get some breathing gas from somewhere, otherwise they wouldn't live very long. And so from the inside of the bell they're able to activate valves, which turns on the onboard gas system so that they're able to breathe. The bell is at the moment situated over the top of the Balmoral Template. We're on top of the riser manifold at the moment. What we can see now in the picture that we're moving down to is the positioning transponder. This sends out a signal constantly, which the ship, which is 135 meters above us, can lock onto using its computers. This ensures that the ship is in the correct position before the bell is launched. That's the bell clump weight we're looking at, and just a shot up above we could see the bell trunking. See, the bell lights are switched off at the moment. We'll shortly take a video pause until something a bit more exciting happens and explain what's going on as we go along. The RCV was just looking up there to check the umbilical, that it wasn't fouled or snagged on anything. As we can see, the fish tend to follow the lights. And what we can see in the picture now is the production trees in the well bays on the Balmoral Template. We shall pause the videotape here until such a time that the diver comes across to the worksite, and we'll shoot some coverage of him actually performing some task or other, probably connecting up the jumper spools, which are the pipes that we're looking at now, to the production tree at well bay number 5. The bolts in the bottom of the picture will be used to fasten flange to flange. What we're looking at now is one of the guide posts on the well bay, and we saw the guide rope there briefly, which runs up to the surface where the rig is positioned. What we're looking at now is the top of the production tree. It's called a tree because of the shape. It doesn't grow any apples or anything, just grows barrels of oil and makes everybody rich. The task today for the diver is that the cap is going to be sent down on a air tugger, and the diver will be positioning the cap on top of the tree. Just notice that one of the guide wires is slack. That's guide wire number 2. Number 2 is denoted by the 2 black rings you can see on the post in the bottom of the picture. And at the moment we've informed the barge control, or the rig control, and they're just about to tension up that guide wire. After a video pause, the RCV has come back to its launcher, where it can be seen we have a slight problem with the umbilical, which we're trying to straighten out at the moment. There's a couple of twists in it. This quite often results in the RCV breaking down. As we can see now, we got the twists out of it. We still have one twist in it, which we'll take out shortly. This is achieved by spinning the RCV on its axis, either clockwise or counterclockwise, depending which way the turn is in the umbilical. And now that the turns have been taken out, the vehicle is making its way across to the worksite, where the diver has at last left the bell and has arrived to earn some pennies. And earlier on I told you about the production tree cap, which would be lowered from the surface. That in fact is the cap that the vehicle is looking at this very moment. And we can see the diver is trying to position it over the top of the tree, which is down below us. And we shall now take a short video pause until such time that the diver has the cap in position ready to be lowered on top of the tree. We can see he's struggling a bit. This is because one of the lines has parted, which ties the tree onto the guide wires and keeps it central between two of the guide wires, two of the diagonal guide wires. And so we'll pause the video. After a short video pause, we can see the diver has managed to manoeuvre the cap to the centre of the tree and is at the moment telling the surface control to lower the tree onto position. And as it comes down into place, we can see that it completely missed its target. And so we'll try again. The diver is having trouble pulling the tree into position, so the vehicle has lodged itself behind and is driving forward, trying to push the tree cap over the centre to enable the diver to lower it into position. As we could see from that little spin on the tree cap, the rope has snapped again. causing the tree cap to spin towards the vehicle, which backed off out of the way just in the nick of time. As the old ancient Chinese proverb goes, a stitch in time is better than two in the bush. Or too many cooks is a shepherd's delight. Or a red sky in the morning is better than none. A stitch in time gathers no moss. And now here we are, a long time afterwards, and the diver has managed to manoeuvre the tree cap into position, and shall shortly be landing it in its final resting place. Just giving instructions back to the surface to come on down on the production cap. It's not such an easy job as it looks to land this cap on here. So there's two keyways which it has to be located into prior to it being lowered, and it weighs about 2.5 hundredweight. So after completing that part of the task, shortly be taking a video pause and taking the RCV for a run round the template and a general survey showing the size, etc. And also probably doing another fish patrol. And the RCV has now returned to its launcher, and we'll give a demonstration of how we park it before we recover it to the surface. What we do is line ourselves up with the front, spin 180 degrees and pull in on the umbilical at the same time, which puts the RCV inside its garage and ready to recover. After that bit of useless information, we're back with the diver, who's tightening up the jumper spools, which we mentioned at an earlier part of the video. Should just mention at the moment that we're right in the centre of the Balmoral template. This is well bay number 5 the diver is working on, and this is the final task before the divers start decompression and the Western Pacesetter 1 moves location to Nig Bay in Aberdeen. Time is now 23:11 on the 19th of July 1986. The diver is at the moment pulling along the hydraulic hoses, which enable him to tighten up the jumper spools. This is done by means of jacks. A jack is placed on the nut. The nut is gripped at one end and stretched, and while the nut is stretched, the bolts are torqued up, or something like that. Either way, it ends up in a tight fit. The RCV is at the moment returning to its launcher. The umbilical is black. The white marks we see on the umbilical are tape marks, which are put on when the umbilical is placed onto the launcher. And the idea being that should the umbilical become fouled up, then we can look at it and ascertain which end is connected to the vehicle. So in the distance, in the top left hand side, we can see the launcher coming into view. And again we go through the motions of putting Snoopy to bed. It's now the 20th of July 1986 at 2 o'clock in the morning. We're just observing feeding time in the big aquarium. The vehicle has just left the launcher. and frightened all the fish away. What we keep looking at the bottom left hand side of the screen is the magnetic compass, which is bolted onto the front of the vehicle. This and the heading on the top right hand side of the screen on the annotation bar tells us what direction we're looking in or heading in. The depth is self-explanatory. The pitch, which is in the centre of the annotation bar, denotes the angle that the camera optic is looking at. At the moment we're looking at minus 72 degrees and heading down towards the seabed. Now reached the seabed at this particular location. It's approximately 143.5 meters, which is a long way down. Now we can see that the seabed is very soft. The fish in the picture there was a ling. It's part of the cod family. But my name's not David Attenborough, and I'm not telling you any more about that. At the moment we're looking at one of the anchors for the template, which was placed here approximately 2.5 years ago, prior to the template being lowered into position. We shall shortly be moving across to the template and doing a quick scout around the outer perimeter fence from the extreme southwest corner to the far northeast corner, just giving some idea of the size and shall be having a look at the pile guides. The piles are still in place. Then going back to the diver to see what he's up to. And finally we shall be observing the diver returning to the bell. The bell will then be recovered to the surface, and so will the RCV. I shall leave the video running on the way from the seabed to the surface and observe the RCV being brought up on the deck. We've now reached one of the legs on the template, which is the extreme southwest corner. This leg is denoted Alpha 4 Papa A4P. As we move along now in a westerly direction, we can see all the spool pieces, which is the pipelines coming off the template, which you saw in the earlier sun video, and which carry the oil from the template wells up to the satellite wells for the injection system, And finally, some of these pipelines return into the template, where the oil will be pumped up the flexible risers to the FPV, which at present has been built in Gothenburg in Sweden. The idea of pumping the oil up to the FPV is so they can separate all the water and chemicals from the oil, which is then pumped back down to the seabed and along the main pipeline to Sullom. All these pipes we see here, yet the divers have to connect all the spool pieces and pipelines up at a later date. There's only a certain percentage of them connected up at this time. No doubt they'll all be connected up when the vessel goes into full production. At the moment we've reached the extreme east corner, which is E19C. Just moving along E19C now, we'll come to a G19C. These bars we see strapped to the templates are sacrificial anodes. The idea being that the seawater will attack them first, rather than attack the metal that the template is made up of, causing heavy corrosion. The anodes are there to protect this from happening. We've now reached the extreme northeast corner on the template, which is demarcation number MI6C. And that's the north face of the template we saw there. And we're now moving back down the east side towards G19C. Another sacrificial anode in the picture there we've just bypassed, and yet another one, which we can see. Back at G19C, and moving southerly towards E19C. Just moving in to look at one of these flow lines now. We can see a valve assembly in the front of it. The diver comes along and operates the valve assembly, which allows water to flood into the pipeline. Then he removes the flange on the end by means of undoing all the bolts, and the pipeline is connected in the place of the blind flange. Just looking up there, we get some idea of the height of the template. Even though there's approximately 4 to 5 meters buried in the sand at this time, there's still a good 8 meters protruding off the seabed. Now we're back at the post on the south west corner, which is A4P, and we start moving up the pile guide itself to the top of the template. Now come up to the pile guide cone, and we can see the pile, which has got all the marks and the rings on. In the centre of the picture, this pile is driven down approximately 90 feet into the seabed itself by the piling hammers we saw on the Sun video. Just to give some idea of the size of this pile, the vehicle has gone down inside it. Remember, the vehicle's approximately 3 feet across. And 2 foot, well, 2.5 feet from stem to stern. That just gives some idea of this pile, which has been driven down through the guide by the boulder, which we saw in the Sun video. The boulder being the big crane barge. And we're at the moment on the outer perimeter fence. And back on the riser manifold. And the dive is approximately around the middle of the template, as was said before, and this gives us a good idea of the actual size of the installation. Got in the picture now is one of the completed production trees. It's the one directly behind the diver, which is denoted number 3. Diver is at the moment working on number 5. Just sit down the vehicle for a few moments and observe the diver working. At the moment he's just clearing up at the end of the job, and will shortly be returning back to the diving bell, which will then be recovered to the surface. The diver just now getting ready to leave the work site. Below us we can see the working basket, which is lowered from the surface on a tugger winch. This contains all the tools that the diver needs for the necessary task, and on a few occasions the surface have recovered this basket without informing the RCV crew, and therefore breaking the umbilical and causing all sorts of problems. The vehicle itself, just the part that flies out of the cage, is worth £90,000, so it doesn't do the company any good to lose them very often. It should be said that it's positively buoyant, and in the event of the umbilical becoming severed, will float to the surface in a matter of minutes, and has a locator beacon strapped on the side, which the rig can then interrogate to locate the exact position of the free floating vehicle, and we get the rig standby boat to recover it, then pass back up to the rig, and a new umbilical fitted to the winch. Fortunately this doesn't happen very often. As we can see now, the tug has been operated on the surface and the work basket is being recovered. Diver standing on the work basket and using it as we would an elevator, and getting a lift back up to the diving bell. There we can see the clump weight underneath the diving bell. Diver will shortly be stepping across, folding up the standby diver's umbilical on the exterior of the bell, and returning to the bell himself. There we get a good view of the bell in the background. Also get some idea of how strong the diver's light is, the head-mounted light, and he's now moving across to the diving bell. At the moment the diver is hanging up the standby diver's gear on the exterior of the bell. and after that he'll be dropping down underneath the bell himself, taking the turns out of his own umbilical and entering the bell. We shall fly the vehicle around the outside of the diving bell and look inside the bell, spy on the divers and give a view of what it's like on the inside. Divers at the moment taking the turns out of his own start again. The divers at the moment taking the turns out of his own umbilical and will shortly be entering the bell. Now the camera headlight has been turned off. And the diver is preparing to take his diving helmet off. The vehicle is now trying to find a window that isn't blocked up so we can take a look inside the diving bell and maybe get a nice little wave of the two divers. difficult to position the vehicle at this moment due to the surge on the bell, and we can see the divers giving us a nice wave through the porthole window. The vehicle is now positioned underneath the trunking, looking up at 70 degrees. See the diver sitting on the seat inside the bell with his feet dangling out of the trunking. And now they've started to operate a hydraulic valve inside the bell and closing the bottom door, thus affecting a seal. After the bottom door is closed, the top door will be closed. There's another door at the top of the trunking. A seal will be obtained and the bell recovered to the surface. Now with the bottom door fully sealed, remains nothing for us to do here but to return to our launcher and commence the recovery of the RCV to the surface, which we're doing at the moment. We pause the video and start again. We started at 24 metres. That's going to be seen from the depth readout on the left-hand side, top left-hand side of the picture on the annotation bar. We're getting closer and closer to the surface. At the moment we're at 11 metres. We're just passing the pontoon on the bottom of the rig. And here we can see the surface coming into view. So we'll be breaking the surface and she'll have a good view of the legs, etc. on the rig. Now we've broken surface, we can see the underside of the Western Pacesetter 1, the flare boom out there to the top left hand side of the picture. And the standby vessel in the left hand side of the column there, the column being the leg. And once the RCV has been recovered on deck, we shall end this short videotape and demobilise the RCV system and return to Aberdeen. The intermittent flashing we could see at the top of the picture there was the strobe going off on the vehicle. It's a pressure switch on the strobe itself. When it gets pretty near to the surface, less than 1 atmosphere, the strobe will start flashing and allows us to locate the vehicle should it part from the main umbilical. See the reflection of the strobe going off. And there's nothing much else to see, so we shall now end the videotape. Bye! That's all, folks.